Okay. And here again, the spacing, the accuracy of the modometer is good too. This will give you a good exercise in getting the motometer working accurately to measure how far along you are. So I want everybody to learn the concept of phase and distance. In the original one that I built during the 1970s, I had a radar system in it. So it tracked the environment by radar motion, so that as you pushed it across, it used radar to see everything around you and position itself in the frame of timing. In which case you don't have to ride it on a surface, you can just swing it through midair and it'll pick up the radar signals. Here, we can roll it along a track and measure the distance. So I want everybody to understand, okay, we're going to measure how far along we are and clock through the process and try to get it to line up. You know, this is pretty good. You know, we caught the wave at the other end, more or less. You can have some fun with this, learn how to use it, learn how to do it. This one here, I think the problem with this is the grat is a little bit too strong on this one, the solid grat. What I find is you want to be able to adjust the grat. So if you look at any good oscilloscope, or oscillograph as they used to call them, the graticule can be adjusted in terms of intensity. In fact, the knob that turns on the oscilloscope is often the brightness knob for the grat. And so usually it's a light bulb with a resistor to control how bright the bulb is shining into and you can turn the grat upside down to go red, or it can be white in the old oscilloscopes. But the ability to adjust the grat. So some of you had a way of, had taken that into account where you want to be able to tame the grat down. I'm not a big fan of a solid grat because it doesn't give you as much three-dimensionality. I find I prefer something like a line grat like this because you can see the three-dimensional shape. It's sort of the graphs. In fact, sometimes you can even turn the ball on briefly as well if you want, even between letters or however you want to do it. You can put a brief instant of all the lights on in magenta or whatever color your grat is, so that you can kind of spatialize that and understand it through space a little bit better rather than a solid grat. Here with, again, I prefer some kind of grat. Either this, I would say, is in my opinion, but it's all a matter of personal taste because you could think of it as a blend of art, science, and technology. But in my opinion, that's got too much grat, that's too heavy on the grat, and this is too light, no grat at all. The happy medium is about that much grat, about halfway between where you got some, but not too much. So it's not overpowering like this one, and it's at the same not. It gives you context or spatialization, so you can see that it is a ribbon of text. So this is good. This one turned out pretty good, and I would have probably turned the brightness of the grat down a little bit, so it's just teetering on the brink of visibility, so you can just kind of see it a little bit, but it's not. You probably want your grat to be significantly less bright than the content that you're trying to display on top of it. So when you're going to, especially when you're plotting functions and mathematical material and content, you want your content to pretty much dominate in the grat lines to be a little bit more background. You probably want horizontal and vertical grat lines, so it's a nice, maybe square grat, and but just barely perceptible. This one was quite nice too. Hello, hello, hello. And so and this is Jerome.
And it's the interface, the one with the interface.
Oh, yeah, this was really nice because the student here had an interface. Who is this again?
Gillet.
Actually, why don't you just briefly, why don't you show everybody this, because I thought this was pretty good. Maybe you all want to gather around for a second, just so you can quickly see this interface, because this was quite nice. This is definitely something that's symbolic. Mark.
So basically, it connects to the add room under my identity, and I can control it with the same IP address. It will. So it shows that I connect to the Wi-Fi, and it will start the server at this IP address, and take some time to change.
But the beautiful thing is here you can control it remotely. So while that thing's going,
Yeah.
while one person is using it, another lab partner.
So
another person
I click on it. It can change the color or.
change the color of the text, font color,
Yeah.
gap between the text. You can change the scale. You can change the. Oh, by the way, the graph. I would change that from on/off to maybe a brightness control.
Oh.
So instead of just being able to turn the graph on and off, it'd be nice if you could control how strong the graph was, maybe from
Yeah.
0 to 255 or something, like a little slider or whatever. That would be really nice. Because that way you can set the graph to, depends on your exposure. What you want to do is gradually increase the graph until it just starts to become visible at the exposure you're using. But that's really good. Beautiful. So this is good Wi-Fi, and Ben, I think you also had yours remote control too, right?
Yeah,
Using Bluetooth. So that's good. So Ben did a remote control using Bluetooth. So we've got Wi-Fi and Bluetooth, because this thing is IoT capable. You might as well push the IoT capabilities of the ESP32. It's really good to learn about all of these concepts, like how to control things. So this was really nice to see this, and there's a nice gradient of font. It's quite beautiful, really. Jerome did something kind of fun too. He, with this thing, and then kind of just creatively going off the end of it as an art form. Here's the ece516 again. I got Mark. Mark has the swim going across there. And this is Jerome's. So a couple of these Jeromes, there's these couple of Jeromes here. Now what I did is I animated those 3 Jeromes as a GIF. So I just used convert to convert command line utility to convert those 3 Jeromes to a GIF. And that's actually quite nice. So if you're able to hold still and do repeatability, so especially if you want to animate some phenomenon, like let's say you want to plot the magnetic field current in a motor as a function, or plot the output of a motor as a function of field current, or something like that, or you're trying to plot a graph of something in another extra dimension. You want to do a 3 or 4 dimensional plotting space. You can use time as another dimension. And so you can add in another dimension. So the way that you do that is you repeat your experiment over and over again the same way. When you're doing science, you want to repeat the experiment the same time each time. So if you're going to do something like this, if there's some, especially if there's a phenomenon that's being measured, like if you're catching radar backscatter off of something and you want to be here. So what I typically do is I'm going to mark where I am, and I'm going to say, okay, I'm going to put myself exactly at the edge of that breadboard. You can put a little bit of masking tape on the floor, even where your feet are going to go, and you go here and you go like this, and you move across and you move back. Now, if you're doing radar backscatter, there's going to be some changes. A truck might park in front of the building and change the electromagnetic field a little bit, but it'll be fairly small. If there's a truck outside over on St. George Street that wasn't there during one run and is there now, it's going to be much less than just the position of your body, which will have a major effect on both radar backscatter, acoustics, sound, anything. So it'll have a major effect. I've got, usually I'll wear black clothes to minimize the optical effect. I also have a shirt that's got a fractal Zeppelin type surface on it that absorbs audio too, so it's acoustically black and as well as optically black. So I use that if I'm doing sonar or something. But in any case, if you position yourself the same each time, it helps a lot in terms of being able to repeat the experiment, repeatability. So you slide across once, twice, 3 times. And this is a good example here. So he's in the same, so you want to try repeating the experiment over and over again from the same position. So start the swim at the same spot each time. At the very least, you can make fun animated GIFs with that, even if you're not doing science. This is maybe more some art. So practice that. I will say the other thing is you can learn how to do multiple exposures. You'll notice in some of these I've got the ring lights on a little bit, which is kind of nice. So you can do a double exposure. You guys all know how to do a double exposure. We want multiple exposures. So let's say if you want the phenomenon. So what I've been doing is I'll push the camera. This is a long exposure. I'll start the exposure and pop the flashlight. And so a lot of cameras now, this is, unless you're a prisoner, if you're in the Apple prison, then it's harder to do. You might need an app or something like that. But if you're in the free world, you'll have this. Usually you can go like the Samsung will go up to 30 seconds only because it's an older Samsung, but the newer Samsung will go up to 2 minutes. So you can do an exposure up to 2 minutes long, or however long you want, up to the 2 minute maximum. New Samsungs. So during that exposure, in this case, this was maybe 15 seconds or something, or 10 seconds. So then what you do is you start the exposure and then you decide whether you want to pop the flash near the beginning or the end. Second, and flash sync is second curtain, first curtain, but you can mimic that by just popping at the right time. So you're going to start your exposure. So if you're here, you're going to start your exposure, run into the frame, go pop, and then carry it across. Or you might pop the flash at the end, depends on whether you want to lead or trail. You can also go backwards too if you want to lead. So if you put the flash synchronized to the camera and it's a first curtain sync only, cheap cameras will only synchronize on first curtain, you don't have second curtain choice. A more expensive camera will let you fire the flash at the beginning or end of the exposure. If you flash it at the end, you got a timing issue because you got to know how long the flash duration is and subtract that duration off, and it never really ends. It's just exponentially decay, so you got to decide where it's going to cut off. So it's a lot cleaner and simpler to fire the flash at the beginning because then the burst of energy begins at the beginning and it tails out into the exposure. So for simplicity, first curtain sync is easier. So if you want to achieve the second curtain effect, you just walk backwards. So you see a lot of times if you have a picture of somebody walking with a birthday cake with the candles glowing and you want them trailing behind the person, what a lot of times people will do during a birthday party is they'll do the cake and then for the picture they'll walk the cake backwards so the flash fires and then the candles appear to be trailing rather than leading in front of them. Otherwise you take the picture and it looks like the candles are inversely trailing instead of trailing. So you be aware of what direction you're going and how the flashlight's going to go. The flash pops and freezes the motion, which is kind of nice. The other thing to do is to have your buddy turn on the light briefly. So you've got a buddy, you can experiment a little bit. What you're going to do is you sit here, you've got your lab partner, and you say, would you turn on the light for a quarter of a second? It's sometimes hard with these fluorescent lights to hit exactly a 16th of a second. It's really hard to control it, right? You turn it on, they take a few seconds to come on, they all come on at different times, kind of, because there's this slight amount of delay when the energy hits the light and when it lights up. LEDs are a bit faster and easier and more predictable in some ways. So with an LED, you could gate the LED with some drive circuit to gate it for a specific duration. But it's hard manually to flip a light switch for the same amount of time, so it's hard to repeat that process. But if you practice a little bit, you could stand here and you could tell your buddy, would you turn on the light for like a brief fraction of a second just to light up the whole room a little bit and turn it off again and then move this thing across. Now, instead of trying to get that exactly lined up, what I'll sometimes do is I'll do 2 or 3 tries with the light, and then until I get it right. So let me just show you guys a simple example of that. So if I go, this I think is, put the best in there, and then I've got source material. Source material's right here. So I've got cement, is computer enhanced multiple exposure numerical technique. The way that cement works, let's make that a little bit bigger. Can everybody see that? You have trouble seeing that, maybe move a little closer. Can everybody read that? So I'm going to put, there's cement, which is chapter 5 of the textbook. So chapter 4 is comparametrics, HDR, comparametric equations. Chapter 5 is superposimetric equations, superposition of light. Light has superposition properties. Cement uses the superposition properties of light to do multiple exposures in a mathematically correct way, superposimetrically. So now cement stands for computer enhanced multiple exposure numerical technique. So that's, and that, I put a pound sign, which means it's a comment, so it won't affect it. Now, what I have here is I've got a couple of different, I can comment stuff out, or I can allow, let's say I comment these 2 out right now, and I'll just pick an example here. I'm going to take 2059, 2061, 2062. So you can see I put 111 in front of those. 2059. So I'll pick some of these. So these are the individual exposures. So let's see if I pick some of these. There's an exposure. I'll just take a good example here, like this one here. So here's with the room lights on. So maybe I take that one. So if I take 2045 and then let's say 2048, 2045 and 2048. So cement 2045 and 2048. So 2045, 2048. So 2045, I'm going to put 111. Those are RGB values, right? And then trowel is a tool for applying cement. It stands for to render out or wonderful excellent light vectors. That's what trowel stands for. It's an acronym. Runs the cement. And then the output here is, that's those two images cemented together. So if I go, I'll pick a couple of images. Let's say I want 2045 through 2048. Sometimes what I'll do also is I'll just now 2045 and 2048. So I've just got those ones right there. Get rid of that other stuff that was in there from before because I was cementing together a couple of images. So there's those two cemented together. So I cemented together the exposure of that light swim going across together with the lights being turned on briefly. And what that allows me to do is to pick out a couple of the lights being turned on briefly. And so for example, if I think that's too bright or too much light, so let's say I had this one. That was 45. I could go down to 44 instead, or one of the other ones. So 44 is a little darker. Maybe I run that one instead, and then I got a little bit less. There's the one with the flashlight on. So 2046 is the one, 2047. I think 2047 is a better take with the flashlight. So 2047 and 2048. So I could say, okay, take, instead of 2045, I'll use 2044, which is just a bit darker. 2047 is with the flashlight on, and then 2048 is the trace of the swim. Now I've got three things to cement together, and now it'll give me a little bit of the room lights, a little bit of the flashlight, and a little bit of the so now you can see that actually that doesn't look too bad. And from a scientific point of view, it shows the principle quite nicely. So there's a little bit of room light, so you've got some context. So you can see there's some room light. And this is a 3-exposure photograph. So multiple exposure photography using the computer enhanced multiple exposure numerical technique is a very simple way to compare, to do superposimetrics and to combine these images together. And you can download cement, warecam.org/cement. If you download the cement code, it's something that I wrote about back in the 1980s, 1970s. Originally it was in Fortran, and then I moved it over to C. So it's pretty crummy, badly written code. I'm sure all of you could do a much better job, but it'll give you an idea of what this system is and how to play with images. So I think it'd be a good exercise to cement a few things together and get used to the idea of doing scientific photography, where you document the surroundings as well as the phenomenon. So the idea is to overlay the phenomenon on top of reality. And of course with the eyeglasses, it does this 60 times a second. It doesn't use that cement code that I wrote back then, but use more efficient GPU based code to overlay in real-time running comparametrics and superposimetric equations immediately, so that in a 60th of a second it overlays on top of reality what's happening. So at least you can learn that and understand these multiple exposures. So I want everybody to get comfortable with taking pictures of things, photography, documenting scientific photography, learning how to document the world around them and different phenomena. I came across this Wikipedia as well too. It's got persistence of vision, which actually doesn't really exist. There's no such thing as persistence of vision. It's been disproven as a flawed theory, but it seems to persist. The persistence of vision seems to persist. So if enough people believe it's true, then maybe it's true. That seems to be the way science works nowadays. But anyway, so a number of people believe in this thing called persistence of vision. I prefer to say I'll agree with persistence of exposure if you expose someone to some light, they're going to see something. Like if you see a bright flash of light and you walk around, you close your eyes, you kind of see that persisting in your exposure. But I don't know if we want to claim that it's high-level vision psychologically, or if it's just a phenomenon at a lower level. I say I don't care or know what phenomenon is. All I know is that when you blast somebody with light, it persists. So I'd call it persistence of exposure rather than try and label it vision. I would be, as the scientist, I would take the science that we can do. Psychology is a soft science, physics is a strong science. I'd push it over to the physics end and say that we got persistence of exposure, that humans and photographic media exhibit the phenomena that if you expose them to light, it persists somehow. And without really trying to claim that we understand it, we can still say that it persists. So this is spinning around here, swim sequential wave and printing machine. So this is a good example here because it shows a graticule, a reticle, text, graphics, and images all superimposed together on a rotary swim. And there's a little bit here on other swims further down in this example here. There's an example here of electromagnetic radio waves from 1974. This is perhaps the world's first photograph of radio waves. So that shows some examples. So if you look around, you'll find this in publications and various. This is Wikipedia, which is some people complain that is maybe not a reliable reference because it hasn't passed peer review under science, but there are links there to other articles. So sometimes it's a good place to start looking because then you can look at some of the references here and find something there like, actually unfortunately they just don't have any actual links. Actually, do any of you use Wikipedia? Anybody here have a Wikipedia account? Does anybody here have a LinkedIn profile? How many, raise your hands if you're on LinkedIn. That's good, so at least employers can see it. So it's good to have a presence because, you know, if I'm at MIT hiring, recruiting, looking, you're going to be looking for signs of life. So you want to show some signs of life, show something that you've got action, there's something happening in your life. So I would suggest make a Wikipedia profile so that you can start curating the scientific universe. And then build up some credit, some history. So make the account and start fixing, if you see a spelling error or something, fix it, because then it'll add to your, reputation capital is the word I'm looking for. So what you want to do is build a reputation capital in the scientific world. Publish papers, write papers in the scientific literature, publish in the IEEE transactions on whatever. The IEEE is the world's largest technical society. Publish in the transactions conferences. Publish at our Immersivity conference symposium. Edit a few Wikipedia articles here and there. If you see a spelling mistake or a factual error, fix it. And start correcting, and you start building up a reputation capital so that you're seen as a member of society that's contributing, a contributing member of society. That's what recruiters look for, whether it's grad school, whether it's employment, or even if you're starting your own company, you're still going to ask people to invest in your company. Whatever you're doing, you want some reputation capital to either get into grad school, get into employment, or attract investment capital, attract sponsors, patrons, donors. Even if you're running a nonprofit, it helps. So try and get that. So this article, this thing's a real dog's breakfast. I suppose I should get in there and fix it, but maybe if some of you can fix this. The references, a lot of them don't have links and should have links. But anyway, it's a good first start to learn about something, and you can see persistent vision. Look at the argument, look at some of the references, see what that is. So I hope everybody had fun yesterday. I will shortly, very soon, I'm going to put the Instructable that you'll be able to post to. And I wanted to see where everybody's at and make sure that I can help anybody who's falling behind. I don't want to make sure nobody's nobody going to get left behind. B, those who are advanced, you know, like Ben and
Gillet.
Gillet, you know, there's quite a few of you are quite advanced, so I don't want you to be bored either. So there's fun stuff you can do. So I've tried to structure the project so that there's extra things you can do that are a lot of fun. Like even just setting up the Wi-Fi, Bluetooth, and all that. That's a lot of fun. You can do a little bit of extra. We had a couple of students here who are actually, why don't you guys come up and show? You got the swim running, the swimulator? Yeah, bring that up and then bring your rendering up as well. So what I did is I used to, years ago, used to spin swims around and rotary swims for music, you know, and play music on them and use it as a way of plotting sound functions. And now, so then we did something called the Swimulator. I wrote something called Swimulator originally, and then some of my students and I improved upon it. And now, so I was just giving him the simple exercise of playing around with the Swimulator. And so should we plug it into the TV? Do you think if I plug it into here, will you be able to sync to it? So let's see if it'll synchronize to your, do you want to just pop it on the podium here? And then, I'll just put mine away for a second. And then, yeah, you can, do you want to do it from here? And then another student has done the rendering for the mocoid, which met at the three-dimensional mocoid thing. Is that, oh, you got 4 screens going to mirror it, I guess.
Yeah.
Is Debian?
It's Linux Mint. It's like based on Debian.
Oh, cool. Cool, that's good. Someone with good taste in operating systems.
I'm not exactly sure how to fix this, so can we just?
Yeah, just go for it. Just go for it.
Okay. Yeah.
The problem with HDMI is it never works.
It worked like.
It never works reliably.
So this is like the simulator code that I've been provided with, and then so like we just go down here and run like this radio slim. So
There you go.
right now it's like connecting to the microphone, and it seems like it's just recording like the audio from the surroundings. So I downloaded an app that lets me generate various frequencies.
And then if I try to put a tone there. And you can generate a pure tone.
Like
The sweet spot where
Yeah,
it's synchronizes to the swim.
you get like the sweet spots where you see it kind of, I guess like the rotation kind of like matches like the period of the function.
Yeah, what you have to do is like if you're gonna play at music in A440 is get your swim spinning.
Yeah, like
that.
over there we just saw it, like it kind of.
You see where it grabs.
Yeah, and it's like a little bit hard to capture once you go into like the higher frequencies. But you still do get like these patterns every once in a while. And if we move it like really high up, yeah, sometimes you still get these patterns, but it's a little bit harder to capture, I guess, because it's just like it's just
the other
oscillating.
thing, try plugging it directly in so that you're not going through the mic as well too, right? So you get a cleaner signal. Sometimes how clean the signal is matters too, right?
I haven't figured out how to do that yet, but
Okay, yeah.
But when I try to at least figure out what's going on with this code, I sort of like try making a simulation
Yeah, there we go.
over here.
Desmos.
Desmos, yeah. Desmos is pretty useful in terms of.
Yeah.
So let's say that's like the sound wave, and that particle is kind of like the thing that's just oscillating. And then so right now it's just like oscillating
Up and down.
corresponding to, I guess, like the frequency of what would be like a period is like oscillating in terms of like the frequency of this sine wave.
Yeah.
Or cosine wave. And then I could give it like a spin, so it's oscillating like around the origin, kind of like that. And then we can also.
You guys all know, are you familiar with Desmos, everybody here?
And we could also like, if I just do this.
So for example, what you might want to do.
Add like some more particles, kind of like see kind of the pattern that gets formed. Just increase the number of particles.
The other thing to do is
the frequency of the particle. We could also increase like So if we hit like a sweet spot where B is
Yeah, there we go.
then you get
Now
like
you're talking.
you get like these really nice patterns. And
Yeah.
then
That's kind of running like Swimulator.
that's how I interpreted the simulator to kind of work. If I like decrease the number of particles, it kind of like shows like the shape of it. Yeah, you just play around with the parameters and see what happens. But in the case of like sound waves, the frequency is like pretty high, so you get a lot of this like crazy movements. But if you like kind of just get it right, you will get like some sort of pattern. So.
Yeah, it's a matter of gen-locking the swim to the phenomenon that you're trying to measure. It's like a lock-in amplifier in some sense. The Swimulator functions much like what a lock-in amplifier does with the reference signal. So the rotary speed is akin to your reference signal. So you typically want to do is have the speed exactly rotated. It's like the sync on an oscilloscope. You guys all know how to synchronize an oscilloscope, right?
We get increase like this.
So getting it to sync is really the first step in this. It's kind of related to oscillography in terms of if you want to get an oscilloscope or oscillograph to synchronize to the incoming signal.
But yeah, that's about it, I guess.
And that's the idea when you spin that motor, you know how it sits still? You're spinning with the motor's turning you, or however you want to think about it. You shear the space-time continuum so the speed of sound is 0, or the speed of light is 0, or more generally the speed of the phenomenology propagation is 0, the speed of wave propagation is 0, the speed of rotation is 0. Whatever thing you're trying to observe, you're trying to shear the space-time continuum so that the velocity of it is 0. And therefore you're sitting in that frame of coordinate reference and you can see and understand it.
And then of course, if like there's no frequency to it, you just get a circle.
Yeah.
Which makes sense.
No input. Cool. Okay, that was really fun. Now, where is your other? You want to show your thing here too? I think people are going to like that as well.
Show a quick render.
That's super good.
Is it the mocoid?
Yeah, mocoid. So Meta did a 3D print of that mocoid shape, and then we put that into Blender.
The file? The one I sent you?
Yeah.
No.
It's the render. So there's a quick render in the middle of like text as well.
So that's quite nice because what he's got here is cutting it out so that the text is also put into the shadow. So that three-dimensional shape captures the shape, overall outline, as well as the text that's written in it. And so that's a pretty good
Yeah, and then I have also the actual Blender model too.
yeah.
Kind of hard to control on the board monitor here. Maybe I just
Yeah, the Blender model.
yeah. But yeah, yeah. This doesn't render super quickly on my laptop, but
Yeah, but you get the idea. That's pretty good.
Basic shape.
That's pretty good.
One possible shape of it, at least.
Blender, is this a Debian flavor as well?
This is Arch.
Archland. Oh yes, Arch is pretty good too. Anybody here use Arch? Yeah, Arch is nice. Yeah, that's good. There's the model.
Yep. That's basic, yeah. It's pretty
Yeah, that's pretty good. Everybody here know how to use Blender? So that's pretty good. Why don't send me the Blender, I'll send it to the class and then people can start to play around with it, learn from it a little bit. This is just a fun little exercise, right? So this is our sort of logo or symbol or whatever it is for Sustainable Technology Society, and beautifully rendered.
thing.
So over the weekend, I'm going to put up the Instructable, and then you can post to the Instructable. And in the last 5 minutes, we'll just wrap up. So everybody, if you guys need help or anything, let me know. I'll be around pretty much for the weekend. I mean, I'm going for the swim on Saturday, 2 o'clock, and you're all welcome to come down for a quick dip in the lake at 2. And other than that, I should be around, and if you need some extra office hours or help or something, let me know. And Monday, I've got my other class. Be around to help. I can help a little bit on Monday outside of my class, which is late the afternoon. And then Tuesday, we're going to meet here in this room. Wednesday, we'll decide whether to meet in my hall or here, depending on what's happening, because I was going to maybe bring the hydraulophone in on Wednesday, possibly to here. And other than that, let me know what else I can do to help. Want to get everybody up to speed. And then, any questions?